Hi everyone, how are you today? Can you hear me? Okay, hi. Hi Sebastian, tomorrow is our first day of the internship. Good luck tomorrow. As you said yesterday, you will start with our internship on Wednesday. Yeah, good luck. Okay, so this week is the last week this semester, and today is the last revision. Okay, and today I will give you maybe two small questions. It's MCQ question and it's similar to what you will do in your final exam. Okay, to test you. Okay, but before coming to the question today, uh, we will go very quickly what we did yesterday. Revision. This one we did yesterday already. Okay, revision. The main topics on fluid mechanics. This one is what we did yesterday. Okay, so I will go very quickly. In fluid mechanics, so firstly you will study about you studied about properties. Okay, and the question and properties you can find in lecture and tutorial one, and this one will be included in the final exam. Okay, and properties will include including pressure, temperature, density, viscosity, surface tension coefficient, uh, shaft speed, elasticity, and lapse rate. Besides this, you will maybe you will have a question about vapor pressure or boiling temperature. Okay, this one, uh, you as I said in the final exam, we will have three problems, three, and will be split into 10 questions. You have 10 questions. Yeah, and 10 questions, and maybe you will have from 1 to 2 questions about properties. 1 to 2 questions about properties. Okay, after that is fluid static. Fluid static is mean no moving fluid. Okay, and this one you can find in the lecture 2 to 5 or tutorial from 2 to 4. Okay, and this one is not included in the final exam. This one you have question. You do this one in the quiz already. Okay, and in fluid static, firstly we study pressure variation. Pressure variation is mean when we go up, pressure decrease, and we go down. When we go down, pressure increase. And dp over ds equal to rho z, or dp over dz equal to minus rho z. Okay, and if density is constant, density constant for liquid. Okay, for liquid is incompressible substance. We can assume as density is constant. And when density is constant, Pz minus Po, with Po here equal to minus rho Gz, or Ps minus Po equal to rho Gh. Okay, it's pressure variation. And after that, and pressure variation you can find in the lecture 2 and 3 and tutorial 2. Okay. About the forces, we studied two forces on plane surface and curved surface. Okay, and force on plane surface you can find in lecture 3 and tutorial 3. Okay, and above force on plane surface you can see on the screen. For example, we have a plane surface AB. Okay, so force applied to AB about the direction in perpendicular with AB. The magnitude FAB equal to pressure times area. Okay, and pressure applied to AB will be equal to pressure applied to C, which C is the centroid of AB. Okay, and about the location, because PA higher than PB, it means the force applied to A will be higher than the force applied to B. So total force FAB will be applied to CP a little bit below centroid. It's not FAB will apply to CP. and the distance with C and CP, C and CP equal to delta CP equal to IC divided by LC times area AB. Okay, with LC is the distance from C to pressure zero or water surface in AB direction. Okay, above plane surface. Force on curved surface, you can find in the lecture 4 and tutorial 3. Okay. For force on curved surface, F by B will be divided to horizontal force and vertical force, Fs and Fv. Okay, and Fs, horizontal force applied to the curved surface AB, will be equal to the force applied to a plane surface Mn. Okay, Mn. Now Fs equal to Fmn. So Fmn you can find based on the force on plane surface, direction, magnitude, and position. Okay, it's similar to force on plane surface. Fv, about Fv, the direction of the Fv depends on the position between the water and the curved surface AB. Okay, if the water is below AB, the direction is upward. If water above AB, downward. For example, as you can see in the system on the screen, because the water above AB, so FV downward. Okay. About the magnitude, FV will be equal to the weight of water in the volume from AB to pressure zero. In this system, we have the magnitude FV will be equal to weight of water in the volume ABEF. Okay. Volume and weight of water in the ABEF will be equal to rho of water, volume ABEF, and gravity. Time gravity. Okay. And about the position, FV will apply to the centroid of ABEF. Okay. And when you find Fs and Fv, you can find FAB. Okay. And after that, in fluid statics, we study about buoyancy and stability. This one in lecture 4 and tutorial 4. Okay. Buoyancy. When we have an object and floats on water, we will have a buoyancy force applied to this one, FB. Okay, and FB, because FB is a force, so we have three things to find to understand about FB. Direction upward, because this one is buoyancy. Okay, and magnitude, FB will be the weight of water in the submerged volume. Submerged volume is the blue volume. You can see in the screen. Okay, and the location is going to apply to centroid of submerged volume, centroid of blue one. Okay, it's a buoyancy force. And stability, because for example, we have the objects as shown in the screen. Applied to the object, we have buoyancy force and weight. Weight will apply to central gravity. Okay, and if B above Z, this one will be stable. If B below Z, we have to compare Ix over Vs and Iy over Vs with ZB. If Ix over Vs and Iy over Vs higher than ZB, stable. It's smaller, unstable. Okay, ZB is the distance between Z and B. Okay, and the last one in fluid static is a resist body motion. You can find in lecture 5 tutorial 4. So, and we have linear acceleration and rotational acceleration. Okay, and we have the equation to find pressure when we have, for example, for linear acceleration. Okay, we have equation to find pressure based on linear acceleration in x direction and z direction. Okay, and you can see in the equation, this one. You see, if ax and az is 0, you will have the equation P equal to PO minus rho GZ is the equation you have in pressure variation. Okay, But if a x and a z is not 0, you have to apply this equation to find the pressure, okay, based on x and z. And similar for rotational acceleration, okay, we have equation p z, okay, depends on po and density, uh, angular velocity r and z, okay. And as I said, fluid static is not included in the final exam. Okay, final exam with part 1 properties and part 3 fluid flow. Part 3 fluid flow. This one will be in the final exam. Okay. And for the fluid flow, we have 3 main equations. First one is continuity equation. Second one is energy equation, and the last one is momentum equation. Okay. Continuity equation you can find in lecture 7 and tutorial 6. Continuity equation is mean mass flow rate constant. Okay, mass flow rate constant. And if we have a density constant for liquid, incompressible substance, okay, we will have volume flow rate constant, because you know mass flow rate equal to volume flow rate times the density. Okay, so when density constant, volume flow rate will be constant. Okay, and volume flow rate, as you know, equal to velocity times cross section area. Okay, for air, the density of air is not constant. Okay, air density not constant, and air density based on Idiot equation. This one is Idiot equation to find air density based on pressure and temperature. Okay, so for air, you have to use, you must use the continuity equation is mass flow rate constant, not volume flow rate. Okay. Next one is the energy equation. You can find in the lecture 7, 8, 9, tutorial 6, 7, 8. Okay, because we have energy equation for ideal flow and real flow. We have so many questions about energy equation in the lecture and tutorial. Energy equation is the most important equation in fluid flow. Okay, energy equation will be the equation you can see in the screen. Energy point 1 plus added energy equal to energy point 2 plus extracted energy and S loss SL. Okay, with energy point 1 equal to pressure energy P1 over rho Z plus kinetic energy V1 square over 2Z and potential energy Z1. Okay, similar for point 2. Energy point 2 will be equal to pressure energy, kinetic energy, and potential energy. It's added energy in here is if you add more energy in the fluid flow between 1 and 2. And in this case, for example, between 1 and 2, we have a pump. S added will be equal to S pump. Okay, and similar extracted. If between 1 and 2, we use a part of energy for example, we use for the turbine. Okay, so extracted will be equal to S turbine. And energy loss SL will be equal to major loss and minor loss. Okay, with major loss is F friction or friction loss. This one is what you did in the lab 1. Okay, and F friction will be equal to F L over D V square over 2C is the equation. With F is friction coefficient you can find from Moody diagram. Okay, S minor will be equal to loss coefficient K times V square over 2Z. Loss coefficient K you can find from the table and figure in the course note and textbook. Yeah. And if it's from the question you have ideal flow, it means you can ignore the energy loss. Those only for ideal flow. For real flow, no. Okay. This one is energy equation. Momentum equation you can find in lecture 9 and tutorial 7. Okay. And momentum equation shows that sigma system equal to sigma m out minus sigma m in. okay, m out minus m in. And an example about momentum equation in each direction you can see in the screen. Okay, with in here we have two forks. It's pressure forks at 1 and 2. Okay, and 1 is water in and 2 water out. Okay, so we will have the equation in each direction. So it's a screen. Okay, we did this one so many times. Similar for y direction. Y direction. Okay, and in fluid flow, we will apply 3 equations in internal flow, external flow, and open channel flow. Okay, we have 3 flow: internal, external, and open channel flow. But open channel flow we studied yesterday is not in the final exam. Okay, in the final exam you only have question about internal flow and external flow. Okay, so maybe as I said, you will have from 1 to 2 questions about properties, and from 4 to 5 questions about internal, and from 3 to 4 questions about external. Okay, so totally you have 10 questions. About the internal flow in the lecture 10, okay, tutorial 7 and 8. Internal flow, for example, we have water flow inside in a pipe. And for the internal flow, the resistance is shown by pressure drop. This one is what you see in the lab 1. Okay, and pressure drop delta P when we go to rho Z F friction. Okay, F friction is what you find here, F friction. Okay, or S major. For external flow, the resistance is shown by the drag, with the equation of the drag D equal to 1 over 2 rho V square S frontage area, and CD, with CD drag coefficient. Drag coefficient you can find from the table or figure. Besides the drag force, we have the lift force L. Lift force L equal to 1 over 2 rho V square S CL. Lift coefficient you have from the figure, as I showed you in the tutorial last week. Okay. And open channel flow is what we studied yesterday. Okay, we have equation to find average flow velocity based on Chezy equation or Manning equation. Okay, with in the Manning equation N is Manning coefficient you can find from the table. And we have equation to find wave speed. C to square root of the y is the depth, and this is gravity. Okay, and this one is everything about fluid mechanics this semester. Do you have any question before we coming to the question today? Do you have any question about the revision? This one is what we did yesterday. We did. Okay. Any question? Do you have any question about the revision? No, okay. So today I will give you 2 questions. MCQ question is similar to what you will do in the final exam. Okay. One question about external flow and one question about internal flow. Okay. For example, here, this one is a question about external flow. And I will give you 15 minutes to finish 3 questions in here, 1, 2, 3, and give me the answer. And after that, we will work together to give solution. Okay, I will give 50 minutes. Actually, you have in 1 hour and 30 minutes, you have 10 questions. It means you have 9 minutes for 1 question, but now you have 5. Okay, 5 minutes for 1 question. 1, 2, 3. You have 15 minutes, and Please let me know if you have the answer. Okay, and you can ask me any question. Okay, start. You have 15 minutes to finish this one. AAB. Okay. AAB. Just only in 5 minutes. That's good. AAB. Okay. So anyone have the different answer? Maybe you wait for maybe 5 more minutes. (1.225 kilogram per meter cube). It's standard condition. The density is a standard condition. And standard condition you can use in the density in the table in the cost note. Let me see. Oh, you don't know where it is? You can download the course note on UTS Online. Course note on UTS Online. Okay, and in the appendix, you have here and standard condition and standard. Here is one appendix and page 2, appendix 2, and standard condition. Okay, density is 1.23. Okay, yeah, you can use 1.23, 1.225. Small, a small difference. That's it. That's okay. Okay. One. So the answer is AAB. Yep. AAB. You choose A, B. Okay. Then and you see Yang. Do you have any the different answer? Can you show me the answer for question 1, 2, 3? If you got it. Okay, AAB. That's good. First two are same. Yep. Yep. It means so the answer will be AAB. Okay, A, B. So let's see. And I can see all of you have the right answer. That's good. Reynolds number, question 1, equal to rho V D over mu. There's only one equation. You will have the answer. With D is 4 meter, density 1.23 kilogram per meter cube. V, we have 6 meters per second. And viscosity, you can find from the table. Yeah, and standard condition. Viscosity will be equal to 1.79 10 minus 5. Okay, it's 1.79 10 minus 5. So we have the Reynolds number is yes, around 1.65 times 10 power 6 is question A. Okay, so the answer is A. Well, I have just prepared this question, so maybe it's too easy. Or maybe the question in the final exam will be a little bit harder. It's okay. The drug coefficient CD. CD. CD for smooth sphere with Reynolds number is 1.65 times 10 power 6. Okay, we use this one, smooth sphere. 1.65 10 power 6 is around here. We use this one is 10 power 6, 1.65 here, smooth sphere. Okay, so maybe it will be okay. So we'll be here a little bit higher than 0.2, a little bit higher than 0.2, smooth sphere. So the answer is CD will be 0.21, or answer is A. Okay. Question 3. Drag force D. Drag force D. D equation in our what the here the revision. The equation you can find in the revision. Drag force. Okay, drag force here. D 1/2 rho v squared S CD. Okay. So D 1/2 rho v squared S CD. With CD is 0.21. Okay. Density 1.23. Velocity you have here is 6 meters per second. S frontage area pi d square over 4. Okay, with d is 4 meter. Okay, so you will have drag force is around 58.4, and the answer is C. Correct. Sorry, B. AAB is the correct answer. Okay, AAB. Got it? So this one is the first one. Okay, saying all you have the right answer. Question 2. This one you have 15 minutes again. Okay, I give you 15 minutes. This one is internal flow. Internal flow. Okay, we have 4 questions. You have 15 minutes, and please give me your answer when you finish. BCCI. Okay, you have BCCI. Okay. Why you think that is maybe wrong? BCCI. Maybe we wait for 5 more minutes. 5 more minutes. The table is a standard condition. The standard condition of what? It means the viscosity of water. Okay, for viscosity of water, you see you have water at 20 Celsius. You don't have to use a standard condition. Okay, water here you have this one here 20 water at 20 Celsius here. Okay, this one is physical properties of water based on temperature at 20 Celsius. You have the density here. You have the viscosity at 1.002 and minus 3. Okay, density you can use 1000. Okay, but viscosity depends on temperature. Okay, is 10 power 3. Viscosity times 10 power 3 equal to 1.002. So viscosity will be equal to 1.002 times 10 minus 3. Okay, you see viscosity times 10 power 3 equal to 1.002. Okay, so maybe the answer is you think that the answer is correct or wrong? Okay, you mean the answer, you think that the answer is correct? Okay, so we have the first answer BCCI. Yeah, BCCI. Anyone have the different answer? Wait for few more minutes. Okay, few more minutes. Hi, Zen, Xiun, and Yu Xiang. Do you have your answer? The first now. The materials of part. Okay. Now you don't have to worry about the material. Consider the material because we have the word roundness here. It's mentioned in the question already. Word roundness is 0.045 millimeter. Okay. From the material, you can find the roundness based on the table on the cross note. But in this question, the question, the roundness is mentioned in the question already. Yeah. So, Yu Xiang, how about your question 1 and 2? The answer for the question 1 and 2. Yu Xiang, the answer? BCC. Oh, same. BCC. Same with Sebastian. Okay, maybe we start now. That's good. Okay. So first one, velocity. Okay. So we have velocity equal to Q over cross-section area. Volume flow rate divided by cross-section area. Okay. With volume flow rate 100 liters per second or 0.1 meter per second. 0.1 meter per second. Okay. And area is pi d square over 4 with d is the diameter here. 20 centimeter diameter is mean 0.2 meter. Okay, 0.2 meter. So from here you have velocity is 3.18 meters per second. Yep, the answer is correct, B. Okay. Question 2, Reynolds number. Okay, with Reynolds number, rho V D over mu. Rho V D over mu. With rho 1000 kilogram per meter cube, water constant. Okay, velocity 3.18 meters per second in question 1. Okay, so you see if you have the wrong answer in question 1, question 2 wrong. Okay, D is 0.2 meter, and viscosity, as you can see in the table, yeah, with at 20 Celsius, viscosity times 10 power 3 equal to 1.002. So viscosity will be equal to 1.002 times 10 power 3. Okay, so minus 3. Sorry. Okay. So the Reynolds number you have here is 6.4 times 10 power 5. Okay, 6.4 times 10 power 5. 3. Friction coefficient F. Friction coefficient F We find F for internal flow. F will based on Reynolds number 6.4 10 power 5, and epsilon over D is rounded. Rounded is 0.045. 0.045 divided by millimeter. Diameter is 20 centimeter or 200 millimeter. Okay, so this one will be equal to 2.25 times 10 minus 4. Okay, so now multi diagram. Okay, multi diagram. This one. We have Reynolds number is 6.4 10 power 5. 6.4. Here is 6. Okay, 6.4. Sorry, yeah, it's 6 here. 10 power 5 here. So 6.4 will be here. Okay. 6.4 10 power 5, and the roundness is 2.25 10 minus 4. This one is 0.0002, 0.004. So 0.000225. 225 may be here. Okay. So we draw a curve. Okay, and okay, we have this one. F a little bit above 0.015, above 0.015. So just have a look in the answer. We have 0.3, 0.5, 0.016, and 0.014. So the correct answer F is 0.016. Oh, this one is the answer here is let's see. In the question 2 is C. Yeah, you correct. And question C. Yeah, correct. Okay. BCC is correct. Now it's 4. Question 4. Pressure drop delta P. Equation to find pressure drop. We have yeah, pressure drop delta P. Okay. Delta P equal to rho Z at friction. Okay. Equal to rho Z S friction SF. Which rho is 1000. Gravity is 9.81. Okay. SF at friction. We have the equation here. SF at friction equal to F L over D V square over 2Z. Okay. So we have F L over D V square over 2Z. With F here we have 0.016. Okay. L length. The length 1000 meter. Diameter 20 centimeter is 0.2 meter. Okay. Velocity in question 1 3.18 meters per second. Gravity 9.81. So we have SF is 4.05 10 power 5. This means we have the question, the answer is A. So you write. Okay, you have 4 marks. 3 marks in question 1, 4 marks in question 2. Okay, 7 marks already. Okay, so it's easy, huh? It's not too hard. Okay, you got it? So because you do it too quick, so I have one more question for you. This one. MCQ. Okay. We have a inventory. Okay, inventory. You have 10 minutes to do this question. 10 minutes. Please give me your answer when you finish. This question a little bit harder. It's harder than the two first question. You got D, none of above. Okay. You don't think you're correct. Okay. You choose D. It's harder. Okay, no idea. Okay, none of you above. Okay, okay. Now we will start with this one. Okay. So let's see the question. First, we have water at 20 Celsius. Okay, it means from this one you can find property of water. Okay, air zone with Q 10 liters per second. Okay, or Q is 0.01 meter cube per second. Okay. You think you know the problem? What is the problem? Need to add the attitude pressure to the cavitation pressure. No, the cavitation pressure is absolute pressure already. Okay, it's absolute pressure already. Cavitation is a pressure of water inside the station 2. Okay, it's absolute pressure already. Yeah, that's point 1 is not absolute. The point 1 here you see is gauge pressure reading P1. This one is P1 gauge pressure is 30 kPa. So P1 is P1 gauge pressure plus P1 absolute pressure. Okay. And this one is strict. And this absolute pressure is not at the standard condition or sea level. This one at 2 kilometer altitude. Okay. At 2 kilometer altitude. The diameter is 60. Okay. Because you see the whole arrangement is horizontal and at 2 kilometer altitude. You can ignore the losses for the cavitation to accuse. Cavitation is station 2. Remember why we have cavitation? When we P2 equal to vapor pressure, sorry, PV, and PV at 20 Celsius, okay, because water temperature at 20 Celsius, and PV at 20 Celsius, okay, at 20 Celsius, you have vapor pressure at 20 Celsius is 2.34 kPa. This means P2 will be equal to 2.34 kPa. And this one is absolute pressure. Okay, absolute pressure. So now what we have, summarize what we have here. We will have P2 is 2.34 kPa. Absolute. Okay. P1 equal to 30 kPa. But this one is gauge pressure. Okay. So P1 will be equal to 30 plus atmospheric pressure at 2 kilometer altitude. Okay. Because everything is placed at 2 kilometer altitudes. And at 2 kilometer altitudes, here, the atmospheric pressure is 79.5 kPa. 79.5. So P1 will be equal to 30 plus 79.5 or 109.5 kPa This one is absolute P1. Okay, so maybe Sebastian problem is here. Okay, so now because it's asked you to find the diameter, okay, to cavitation occurs as a station 2. Okay, so in this case, we write the energy equation between 1 and 2. 1 and 2. Okay, so we will have P1 over rho Z, V1 square over 2Z. That's 1. Okay, go to P2 over rho Z, V2 square over 2Z. That's 2. Okay. With Z1 to Z2, same. Okay. P1 we have is 109500 Pascal. Convert to Pascal. Density 1000. Okay. Gravity 9.1. P2 2340 Pascal. Okay. V1 we have is Q divided by A1. Okay. With Q is 0.001. 0.01 meter cube per second. Area 1 pi d1 square over 4. Okay, which d1 is 60 millimeter or 0.06. This one is 0.06 meter. Okay, only V2 we don't know, but V2 will be equal to Q divided by A2. Okay, which Q is here, and A2 is pi d2 square over 4. Okay, so from this one you can find d2. Okay, and the correct answer here is C, 29 millimeter. Okay, the correct answer here is this one, 29. Okay, you got it? So be careful, okay? Because here you have gauge pressure reading. Okay. Got it? Okay. Thank you. So now is that everything I want to show you to prepare for the final exam. Okay. Let me see. The revision, that's okay. And if you want, I will send you this revision, what we did yesterday in the email, maybe today or tomorrow. I will send you this one. Okay. And if you have any question from now to before the final exam, you can email me. Okay. And one more thing, I will want to remind you that this Friday is the due date of the lab 2. Okay. You have any question? Any question? Okay. All good. So if you don't have any question, thank you. And maybe I will see you soon when you do the final exam. Okay, I will be available when you do the final exam. Okay, please email me if you have any question about fluid mechanics, about the lab 2 or about the final exam. Okay, any question? Thank you. Bye bye. Bye, Sebastian. Good luck for the internship tomorrow. Bye bye. See you.